This video is the fourth of a 6-part video series that aims to provide an overview of wastewater operations at meat processing plants and guidance on their day-to-day management. This video will discuss the aerobic treatment of wastewater. Aerobic microorganisms need oxygen to decompose organic waste in a process called oxidation. As discussed in video 1, biochemical oxygen demand, or BOD, is the amount of oxygen available in 1 litre of wastewater that would be consumed if all the organics in that water were oxidised by bacteria. If treated wastewater is still high in BOD when it is discharged, then bacteria will consume the available organics and oxygen and rob other aquatic organisms of the oxygen they need to live. It will also create odour issues. The main purpose of aerobic ponds is to reduce BOD concentrations and to ensure that there is a reasonable level of dissolved oxygen in the treated water. They are typically large, shallow ponds, often less than 2 metres deep, which are commonly found downstream from anaerobic ponds in meat processing wastewater treatment systems. There are 3 main types of aerobic ponds: facultative, aerated and maturation ponds. Facultative ponds are probably the most common aerobic pond in meat processing wastewater treatment systems. They are cheap to build relative to other technologies and need very little operational input, including no energy input. The pond operates as 2 horizontal layers. In the top layer, sunlight encourages the growth of green algae, which photosynthesizes in daylight, producing oxygen which keeps the top layer aerobic. This layer can have a musty smell. The deeper anaerobic layer performs exactly like an anaerobic pond. The only difference between a facultative pond and an anaerobic pond is that facultative ponds have a lower BOD added to keep the anaerobic layer at a reasonable depth. For example, if an abattoir doubles its throughput without increasing the volume of upstream anaerobic ponds, then the downstream facultative pond may become an anaerobic pond, as the extra BOD entering each day quickly consumes oxygen in the upper layer. In essence, the aerobic layer shrinks to nothing. In these situations, ponds can cause odour issues. Aerated ponds are increasingly common and can overcome the main limit of facultative ponds, which is the ability to add enough oxygen to keep an aerobic top layer. Rather than depending on algae to oxygenate the top layer in aerated ponds, oxygen is provided by mechanical floating surface aerators or submerged blower aerated systems such as air stones. Sometimes only enough air is supplied to ensure the top layer is kept aerobic, or enough air is supplied to aerate the entire volume of the pond so there is no anaerobic layer. This is called a completely mixed pond and demands higher levels of power but less land than facultative ponds. Because aerated ponds are not dependent on less reliable natural or seasonal factors, such as algae, they are more effective at removing organic loads compared with facultative ponds. They are, however, more expensive to construct and have ongoing energy costs to operate compared with facultative ponds and can produce significant levels of sludge over time. Maturation ponds are shallow ponds, often less than 1.5 metres in depth, that are designed mainly to achieve disinfection by reducing pathogenic microorganisms as well as reducing BOD to low levels. To do this effectively, they have treatment systems upstream, such as facultative or aerated ponds, which reduce the incoming BOD load to very low levels. The shallow ponds allow sunlight and oxygen penetration to the base of the pond. Often they are green with algal growth, which provides a rich dissolved oxygen concentration and have a high pH, which helps to kill pathogens. To achieve a good degree of disinfection, wastewater needs to be retained in the pond for 20 days or more. Site-specific regulatory requirements concerning aerobic ponds will be stated in the facility's Environmental Protection Licence, Permit or Approval, which is issued by state government. Probably the most common requirement is for the pond to have a certain freeboard to prevent overflows. Well-managed aerated and maturation ponds will have 0 emissions. The only uncertainty would lie with facultative ponds. Operators should inspect aerobic ponds at least once every week and confirm that the inlet and outlet are clear of blockages. If the pond is aerated, then they should also ensure the aerators are functioning properly. Unlike anaerobic ponds, you want to make sure there is no crust or substantial foam on the pond. Crusts prevent good aeration of the water and are a bad sign for aerobic ponds. Operators should also check pond walls for damage by emerging trees or shrubs that should be removed immediately, burrowing animals that should be evicted, or rain erosion. It may pay to apply protective biodegradable matting which allows grass growth and protects from erosion. Sampling and testing of the discharge of each pond on a regular basis is recommended. Simple grab samples of the incoming anaerobic treated and outgoing aerobic treated effluent are usually representative and reproducible. When sampling aerobic ponds, it is important to collect the sample from the discharging outlet, as samples scooped from the surface of these ponds may not be representative. For aerated or facultative ponds where treated wastewater is disposed to land, an appropriate sampling frequency is once a month or quarterly. Operating parameters for these ponds vary extensively depending on location, climate and season. If you are unsure, seek expert advice. Parameters that must be tested for compliance purposes and the frequency required may be included in your plant's environmental license. Operators need to watch for various problems in aerobic ponds. If there is any sign of a persistent white Pavlova mix style mousse that often looks like fat, seek urgent appraisal by an expert. Foam is often noticed prior to a rain period when atmospheric pressure drops. This may indicate a pond operating close to its limit. Sometimes maturation ponds suffer an inversion event at the change of season, where the bottom sludge suddenly rises, often overnight, and covers the pond. This is a natural event, and generally the best means of repairing the damage is to use a travelling irrigator spray to sink the floating sludge. Seek expert help if required. Excessive solids in the ponds or outlet discharge may be due to sludge buildup in the pond. This is a particularly common issue when the pond is immediately downstream of an anaerobic pond. In this case, a regular program for removing sludge buildup may be needed. Seek assistance as required. Aerobic ponds may smell musty. This is normal. They should never smell offensive. If they do, it is usually a sign that either the pond has become anaerobic, typically due to BOD overloading caused by a malfunctioning anaerobic pond upstream, or a severe spill of blood or tallow in the previous month. The pond could also have filled with sludge and desludging is required. Operators should keep an eye out for blue-green algae. Under hot, still summer conditions in much of Australia, facultative or maturation ponds may stratify, with the top surface layer of water reaching very warm temperatures more than 30 degrees Celsius. Under these conditions, various blue-green algae can bloom and grow. In the worst cases, these algae can release toxins which can be toxic to personnel and animals if the treated water is recycled, for example, back to stockyards.